x squared minus 3x plus 2 by x minus 1. With respect to factorization, it's very simple problem. But if you'll observe that any limit problem, first we can apply the substitution method. In the substitution method, if the answer is finite, then it is okay. If it is not defined, then we can go for the other method. For example, limit extends to infinity. Limit extends to infinity. 3x square plus 2x by 6x plus 2. Any problem which is in the form of either 0 by 0 or infinity by infinity, those you can solve with the help of differentiation. So everybody knows that the name of the method is L'Hospital rule. L'Hospital rule. So the problems which are in the form of either 0 by 0 or infinity by infinity, those you can solve with the help of differentiation. But here the problem is many of the students, all the indeterminate forms can be solved with the help of this differentiation method. It's not possible, sir. The problems which are the form of either 0 by 0 or infinity by infinity, those only you can solve with the help of differentiation. Usually that method is known as L'Hospital rule. జనరల్ గా స్టూడెంట్స్ ఏమడుగుతూ ఉంటారంటే సార్ మమ్మల్ని చెప్పేటప్పుడు హాస్పిటల్ ఏంటి సార్, మ్యాథ్స్ లో హాస్పిటల్ ఏంటి సార్, ఆ పదం మీనింగ్ ఏంటి సార్ అంటూ ఉంటారు. బట్ మనం ఏ బుక్ చూసినా హాస్పిటల్ రూల్ అనే ఉంటుంది. యాక్చువల్లీ ఇట్స్ నాట్ హాస్పిటల్ రూల్ సార్, ఇట్ ఈస్ హోపిటల్ రూల్. ఇట్ ఈస్ హోపిటల్ రూల్. ఇట్స్ ఎ ఫ్రెంచ్ మ్యాథమెటిషియన్ నేమ్. ద ఫ్రెంచ్ మ్యాథమెటిషియన్ హూ ప్రపోజ్డ్ దట్ the problems which are in the form of 0 by 0 or infinity by infinity, those you can solve with the help of differentiation. The statement was proposed by the French mathematician L'Hopital. ఆ ఫ్రెంచ్ లాంగ్వేజ్ లో ఈ ఓ పైన సంథింగ్ ఇలా క్యాప్ సింబల్ ఏదో రాస్తారు సార్, అది వాడుక భాషలోకి వచ్చేటప్పటికి అది హాస్పిటల్ రూల్ కింద మారిపోయింది. స్టూడెంట్స్ మమ్మల్ని ఒక్కొక్కరు అడుగుతూ ఉంటారు, ఏంటి సార్ అసలు హాస్పిటల్ ఏంటి సార్, అసలు దాని అర్థం ఏంటి సార్. So original name is L'Hopital rule. French mathematician L'Hopital who proposed this rule. So majority of the problems we can solve with the help of this differentiation. Differentiation to solve this is sir maximum which are in the form of 0 by 0 or infinity by infinity. So what about the remaining other indeterminate forms? Sir 0 power 0 by 0 ఇన్ఫినిటీ బై ఇన్ఫినిటీ వరకు ఓకే సార్, రిమైనింగ్ ఇండిటర్మినేట్ ఫార్మ్స్ ఏంటి? ద ప్రాబ్లమ్స్ విచ్ ఆర్ ఇన్ ద ఫార్మ్ ఆఫ్ 1 to the power of infinity. The problems which are in the form of 1 to the power of infinity. 1 power infinity form లో ఉంది. The problems which are in the form of 1 to the power of we can use a shortcut sir for that. The shortcut method is you can compare the 1 to the power of infinity with f of x to the power of sir.
సార్ మీది బోర్డు కనపడదు సార్, మీరు రాసేది
బోర్డు కనబడుతుంది సార్, నేను వేరే మొబైల్లో కూడా చూస్తున్నాను సార్. ప్రాబ్లమ్స్ విచ్ ఆర్ ఇన్ ద ఫార్మ్ ఆఫ్ 1 to the power of infinity, those you can solve very easily with the help of a shortcut. E to the power of the limit whatever is given in the question, that you should apply. Suppose the limit extends to a. Suppose the limit extends to a, you can apply the same. Whatever the limit is given, you can apply. F of x minus 1 into g of x. A very useful and very good shortcut, sir. This is 1 to the power of infinity. The problems which are in the form of 1 power infinity. Any 1 power infinity problem we can solve with the help of this shortcut. A very, very useful shortcut, sir. This is
అది కాదు సార్
e
ఏడో
power
వచ్చినాక
limit
బయట
extends to a.
కూర్చున్నట్టే
Here
ఉంది.
a means whatever the limit given in the question that you should apply. E power limit extends to a f of x minus 1 into g of x. E power limit extends to a f of x minus 1 into g of x. A very useful shortcut, sir. Now we are going to discuss some problems related to this. For example, sir, the shortcut is very useful shortcut, sir. This is e power limit extends to a f of x minus 1 into g of x is very, very useful shortcut it is. So I'm going to add one general basic problem. First I will explain a simple problem. Later we will discuss the remaining different problems also. Suppose limit extends to 0. 1 plus x 1 plus x whole to the power of 1 by x. So in intermediate textbook directly we can teach it formula as e 1 plus x whole to the power of 1 by x. సో జనరల్ గా స్టూడెంట్ ఏం చెప్తా ఉంటారు సార్, ఈ ఫార్ములా ఆన్సర్ ఈ అని ఐడెంటిఫై చేయడానికి 2 మెథడ్స్ ఫాలో అవుతాం. ద వెరీ ఫస్ట్ వన్ ఈస్ 1 ప్లస్ ఇక్కడ ఏవైతే ఉందో సేమ్ ద సేమ్ విల్ రిపీట్ 1 ప్లస్ ఎక్స్ హోల్ టు ద పవర్ ఆఫ్ 1 బై ఎక్స్. రెసిప్రోకల్, ఇఫ్ హియర్ ఎక్స్ ఈస్ దేర్ ద పవర్ మస్ట్ బి రెసిప్రోకల్. If the same thing is there, directly we can write the answer as g. But you can use this shortcut also. E to the power of limit extends to 0 f of x minus 1. Here the base is 1 plus x. F of x minus 1 into g of x. As well as x extension, the final answer becomes e. Like this, you can solve any problem which is in the form of 1 to the power of infinity. This is basic problem, sir. But whereas in case of the problems, some higher problems, while we are solving, we need to use L'Hospital rule also, alias L'Hospital rule. I am erasing the screen. For example, limit extends to 0. Limit extends to 0. A power x plus b power x by 2 whole to the power of 1 by x. Suppose our question is limit extends to 0, a power x plus b power x by 2 whole to the power of 1 by x. You will observe that the base is 1 and the power become as infinity, 1 power infinity. So simply you can use the shortcut e to the power of f of x minus 1 a power x plus b power x by 2. I am writing the LCM directly by 2, that means minus 2 whole by 2x. It becomes limit extends to 0, a power x plus b power x minus 2 whole by 2x. If you will observe that it is in the form of 0 by 0. So majority of the questions will be in the form of either 0 by 0 or infinity by infinity. Either 0 by 0 or infinity by infinity. Majority questions. So here, when the question in the form of 0 by 0, immediately we can apply the derivative. E to the power of a power x log a plus a power x log a plus b power log b minus 0 by 2
సార్ చూశాను.
by 2. Next, express the 0 substitute చేసేయండి సార్.
పవర్
By
కటింగ్
simplifying, we will get the answer e power 2 log ab. Finally, root ab. Finally,
ఇది ఎప్పుడు
root
అప్లై
ab.
చేసింది? సరే నేను చేపిస్తాను.
We can solve the problems which are in the form of 1 to the power of infinity with the help of the shortcut e power f of x minus 1 into g.
సరే అయిపోయిన బట్టి మీకు పెడతాను సార్, ఏముంది. సరే ఇంకా 2 ఉన్నాయి కదా. సరే
But some of the students will ask the proof of 1 power infinity formula also generally. If required, we can prove that also.
సరే సరే ఇప్పుడు పవర్ వచ్చిన బట్టి చేపించు.
So I'm going to the next page of the whiteboard. So first we discuss 0 by 0. Next we discuss infinity. From these two, by generalizing, we can write distance 0
ఏమో నెట్లో కూడా చూసి
a power x plus b power x by 2 whole to the power of 1 by x
అందుకే దాన్ని పెట్టాడు.
root ab. After getting the proper knowledge for the students, you can generalize these results as some more shortcuts. If you can write limit x tends to 0 a power x plus b power x plus c power x by 3 whole to the power of 1 by x. You can generalize it as cube root of ABC.
నాకు ఇచ్చిన ఆ 10
So totally,
6,000
I covered 3 indeterminate forms. The first one is
అనుకుంటే
0 by 0 or infinity by infinity. 0 by 0 or infinity by infinity. And next one, 1 to the power of infinity. Majority questions are in the form of either 0 by 0 or infinity by infinity or 1 to the power of infinity. Later some more indeterminate forms we are going to discuss. Limits అంటే ఎక్కువ indeterminate forms అనే questions ఉంటాయి సార్. Either 0 by 0 or infinity by infinity or 1 power infinity. So 3 indeterminate forms are covered: 0 by 0, infinity by infinity, 1 to the power of infinity. Suppose 0 into infinity is there. If the question is in the form of 0 into infinity is there, then what we can do? 0 into infinity form. Then we should convert the 0 into infinity form either 0 by 0 or infinity by infinity. I am writing one question regarding that. The problem which is in the form of 0 by 0. Just a moment, sir. If the question is in the form of 0 into infinity, I am writing one question regarding that. Limit x tends to 1 minus x into tan pi x by 2.
బియ్యం
1 minus x into tan pi x by 2. If you'll observe that the question is in the form of x tends to 1, 1 minus 1, 0, and tan pi x by 2, which is infinity. So it is difficult to solve. 0 into infinity means indeterminate form. Now we can convert this problem into 0 by 0. Limit x tends to 1 and 1 minus x 1 minus x by pi x by 2. Limit x tends to infinity. Limit x tends to 1, 1 minus x by cot pi x by 2. If you'll observe that the question is in the form of 0 by 0, whenever in the form of 0 by 0, again you can use L'Hopital rule or L'Hospital rule, whatever. Then you will get the answer. 0 into infinity. 0 into infinity form. So, like this we can solve the problems which are in the form of 0 into infinity. So, 4 indeterminate forms are covered. Sir, why I am concentrating indeterminate forms means many of the questions are related to indeterminate forms, either in the MSET or in the JEE main or in the advanced also. Okay, one more model. One more indeterminate form. Suppose the given question is in the form of infinity minus infinity. A previous question we are going to discuss which is in the form of infinity minus infinity, a different and good question. The question is limit x tends to 0, limit x tends to 0, 1 by limit x tends to 0, 1 by sin square x minus 1 by sin h square x. 1 by sin square x minus 1 by sin h square x. ఇది ట్యాబ్లో రాస్తున్నాను సార్, స్పేస్ సరిపోయిన వరకు రాస్తున్నాను. లిమిట్ ఎక్స్ టెన్స్ టు 0, 1 by sin square x minus 1 by sin h square x. So if you'll observe that it is in the form of infinity minus infinity, minus sin square x minus sin square x whole by here one step I am going to write directly, which it is x to the power of 4. Sir, observe that instead of the denominator sin square x sin h square x, I wrote x power 4. Because so whenever sin square x is there, we can divide with x square and by multiplying with x square. According to the trigonometric limits, limit x tends to 0, sin x by x is also 1. The same logic applicable for sin hx also. So that's why here one x square, here another x square. This is little a tough question, because if you will substitute this 0 in the given function, it will be in the form of 0 by 0. 0 by 0. Here the problem is how many times we need to apply this L'Hospital rule for this function. If you will apply 0 by 0, if you will apply 0 by 0, again the resultant step is also in 0 by 0. If you will observe again it is in the form of 0 by 0. So we need to apply this L'Hospital rule or L'Hopital rule. We need to apply 4 times. 4 times L'Hospital rule. So then you will get the answer easily. Just observe that, sir, once. Okay, sir. Now the next one. So now a very important concept. Just before that, one more additional point. 0 by 0 is covered and infinity by infinity is covered. 1 power infinity is covered, as well as infinity minus infinity is also covered, and as well as 0 into infinity is also covered. Then some more indeterminate forms will be there. Sir, ఇవన్నీ కాకుండా న్యూ ఇండెటర్మినేట్ ఫామ్ ఇంకొకటి వస్తే ఏంటి? For example 0 power 0, 0 power infinity, or infinity power 0, or some other. Then what we need to do? So దీంతో maximum indeterminate forms questions అన్నీ అయిపోతాయి వీటితో. So 0 by 0, infinity by infinity, L'Hospital rule. So next 1 power infinity, I taught a shortcut, e power f of x minus 1 into g of x. And next infinity minus infinity, convert it into the form of 0 by 0. 0 into infinity, convert this in the form of 0 by 0. Later, suppose వస్తే మరి ఏం చేయాలి సార్? వీటికి షార్ట్ కట్స్ ఏంటి? If any power and base other than 1 power infinity, that you can take as y as the question. Suppose the question is y is equal to limit x tends to 0 x to the power of x, taking log on both sides. By taking log on both sides, definitely you will get one of the indeterminate forms above what we are discussed. 0 by 0 or infinity by infinity, definitely you will get. Again, by applying L'Hopital rule, you will get the answer. Okay, sir. Next one. So maximum all the indeterminate forms are covered. Limits అంటేనే ఎక్కువ indeterminate forms వస్తాయి సార్. మెజారిటీ ఆఫ్ ద క్వశ్చన్స్ ఈ కాన్సెప్ట్స్ మీదే ఉంటాయి. 90% L'Hopital rule, remaining 1 for infinity. Next, all this. Any new indeterminate form is base power, taking log on both sides. You will get either 0 or infinity by infinity. Next one, a very important concept, limits by using some expansions. First, I will explain with a basic example. Generally, we can write limit x tends to 0, e power x minus 1 by x. Limit x tends to 0, e power x minus 1 by x. Directly we can write the answer as 1 generally. స్టూడెంట్ క్యాచీగా ఉంటుందని ఈజీగా ఉంటుందని ఏం చెప్తా ఉంటే మీరు మేము అందరం కూడా ఈ పైన పవర్ ఏ ఉంటే డినామినేటర్ లో సేమ్ ఉండాలి. దెన్ ఇట్ బికమ్ as 1. If we will discuss the proof, sometimes the shortcuts are not applicable. Sometimes then you can do the procedure. For example, we can discuss or we can prove the same sum in distinct ways. The first one, student ఈజీగా అర్థం కావాలి. ఈ పైన పవర్ x ఏంటి, denominator కూడా x. If e power 3x, denominator also 3x, the answer should be equal to 1. That is one form. The another one is, if you will substitute 0 in this, it is in the form of 0 by 0. 0 by 0. 0 by 0. So whenever 0 by 0 is there, simply you can apply L'Hospital rule. The derivative of e power x is e power x. And constant derivative 0, x derivative 1, e power 0, the answer is 1. Simply. But sometimes in some difficult JEE advanced or MSET or JEE main, expansions are required. Problems by using expansions. For example, I am going to write the expansion of e power x. The expansion of e power x. E power x, we can write it as 1 plus x power 1 by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus so on. This is the expansion of e power x. With the help of this also, we can prove it e power x minus 1 by x as 1. Because e power x plus 1 come to this side minus 1. Simultaneously, x is common in remaining all other terms by x. By taking limit x is equal to 0, limit x tends to 0, this whole part becomes 0, and we can prove that it as 1. So limit x tends to 0, e power x minus 1 by x is 1. So that is okay. సో మీరు మేము అంటే ఫ్యాకల్టీ మెంబర్స్ కాబట్టి మ్యాక్సిమం ఎక్స్పాన్షన్స్ అని మనకు గుర్తుంటాయి. బట్ స్టూడెంట్స్కి అన్ని ఎక్స్పాన్షన్స్ గుర్తుంటాయని చెప్పలేం, వాడు గుర్తుపెట్టుకోవడం కూడా కష్టం. దానికి ఈ పవర్ ఎక్స్, ఏ పవర్ ఎక్స్, సైన్ ఎక్స్, కాస్ ఎక్స్, జస్ట్ ఐ విల్ షేర్ సమ్. ఓకే సార్, సమాధాన పిక్ అక్కడ మిస్ అయింది. సో ఈ పవర్ ఎక్స్, ఏ పవర్ ఎక్స్, సైన్ ఎక్స్, కాస్ ఎక్స్, ఫర్ ఎవ్రీ మ్యాథమెటికల్ ఫంక్షన్ there is an expansion. So now I am going to explain a shortcut formula which is useful to write any mathematical expansion. ఏ ఫంక్షన్ కైనా సరే ఎక్స్పాన్షన్ రాసేలాగా ఒక షార్ట్ కట్. I hope maximum of the faculty members has an idea regarding this. That is Taylor series and Maclaurin series is there now. With respect to that, this we can apply as a shortcut formula. To write expansion of any function. F of x is equal to f of 0. F of x is equal to f of 0 plus f dash 0 by 1 factorial into x plus f double dash 0 by 2 factorial into x square, and it will continue like that, plus so on. With the help of simple shortcut formula, you can write any mathematical expansion. You can write a power x, you can write e power x, even though you can write log 1 plus x expansion also, and as well as sin x also. A very useful formula of this is, if the student forgot the expansion, then simply the student write this formula and apply f of x. Suppose e power x expansion, just the student can write e power x in place of f of x. Just apply, you will get the answer without any doubt. Similarly, next a power x, log 1 plus x. నేను స్క్రీన్ మీద రాసిన ఫంక్షన్సే కాదు సార్, మాక్సిమం అన్ని ఫంక్షన్స్ ఎక్స్పాన్షన్స్ దీంతో వచ్చేస్తాయి. సో ఏదైనా టఫెస్ట్ ప్రాబ్లం ఎక్స్పాన్షన్తో చేయాలి, స్టూడెంట్కి ఎక్స్పాన్షన్ గుర్తు రాలేదు అంటే ఈ ఫార్ములా యూజ్ చేస్తే ఇమ్మీడియట్గా ఎక్స్పాన్షన్ వచ్చేస్తుంది. బట్ మెజారిటీ ఆఫ్ ది ఎక్స్పాన్షన్స్ కన్సిస్ట్ factorials in the denominator, factorials, whereas in case of the logarithmic expansion there will be no factorials, but automatically those will exist in the formula. While you are doing the calculation, they will exist. So this is a very useful formula. With the help of this, you can write expansion of any mathematical function, sin x, cos x, tan x, secant x, cosecant x, whatever, anything you can write. Next I'm going to explain some shortcuts related to the chapter of differentiation. For example, generally in our intermediate textbook we have 7 mark sums. Find the derivative of x power x plus sin x whole to the power of x. So this is a 7 marks essay question for us, whereas in case of the IP 7 marks essay question అంటే approximately ఒక 10 to 11 steps or 10 to 12 steps వస్తుంది. We can solve this in a single step. ఒకే ఒక స్టెప్ లో చెప్పొచ్చు సార్ దీని ఆన్సర్. When the student understand the shortcut perfectly, shortcut కనుక పర్ఫెక్ట్ గా అర్థం అయితే, then he can able to answer this problem's derivative of this 7 marks essay question in our intermediate syllabus. We can solve this in a single step, only one step, when he is proficient in the shortcut, respective shortcut. So that I am going to explain. So before to teach this, first we need to discuss some basics. So logarithmic differentiation, find the derivative of d by dx of x to the power of x. Generally we can teach like this: y is equal to x to the power of x, log y is equal to x log x, taking log on both sides and differentiating. At last we will get the answer as x power x into 1 plus log x. X power x into 1 plus log x. Derivative of x power x is x power x into 1 plus log x. This is regular standard model. Now I am going to teach the same in a distinct way. So if the student will understand this shortcut perfectly, then they can answer the 7 marks essay question in a single step. So d by dx of x to the power of x, d by dx of x to the power of x. So derivative of x to the power of x, derivative of x to the power of x. The very first and fundamental point is, while you are solving any logarithmic differentiation problem, the first term of the answer is the question. Suppose You are writing the derivative of x power x. You are writing the derivative of x to the power of x. The first term in the answer is x to the power of x. Then you can write a determinant. ఇది యాక్చువల్గా షార్ట్ కట్ బుక్స్ లో ఉన్నది కాదు సార్, మేము కొన్ని క్రియేట్ చేసినవి ఉన్నాయి. ఎక్స్ పవర్ ఎక్స్, write the power at first. Write the power. So in this question we don't know the difference between the power and the base because both are x power x. So I'm highlighting with that red color, x power x. Write the derivative of the power. Write the power. Next, write the derivative of the power. Later take the base with log. Take the base with log x. For the base, write its derivative. Okay, sir. Writing debt. నేను దీన్ని డెట్ సెన్సర్ రాస్తున్నాను సార్, బట్ ఈ షార్ట్ కట్ బుక్స్ లో ఉన్నాయే కాదు, మేము కొద్దిగా మాడిఫై చేసి స్టూడెంట్ కంఫర్ట్ గా ఉండేలాగా కొన్ని చెప్తున్నాం. ఇవి జనరల్లీ matrix debt we can take as AD minus BC. ABCD debt అయితే AD minus BC. To make a shortcut, a small modification for this plus. So directly you can write the answer x power x into write the debt. Is equal to x power x into matrices debt, sir, but actually plus. So there matrices debt AD minus BC కదా, మీరు అలా ఎలా మార్చేస్తారంటే జస్ట్ షార్ట్ కట్ క్రియేట్ చేయడానికి చిన్న మోడిఫికేషన్ ఫర్ దిస్ 1 plus log x, finish. Simply d by dx of x power x is, we can write it as x power x into 1 plus log x. A small modification what I done is here, matrices debt I treated as AD plus BC for this, just to create a shortcut. I'm arranging this. Suppose we need to write another derivative of x to the power of sin x. So previously what I taught, the logarithmic differentiation answer is, the first term is the question. So you can write x to the power of sin x at first. Debt of. First you can write the power. Sin x. Later its derivative cos x. Later first function and derivative. Next take the base. For the base you can write logarithm, whatever the base you can take logarithm. Log x derivative 1 by x అయిపోయింది సార్, సమ్ అయిపోయింది. Then it is completed. The student directly can say the answer, x power sin x into sin x by x plus cos x log x. X power sin x into sin x by x plus cos x log x. Okay, sir. Now I'm arranging the screen. Now the 7 marks question in our textbook, d by dx of x power sin x plus sin x to the power of x. Simply apply the same shortcut separately for this x power sin x. I'm writing here x power sin x det of sin x cos x, and next log x 1 by x. First part completed, sir. Plus second part also. Second part also like that only. Same detail. ఒక్క స్టెప్ లో అయిపోతుంది సార్ క్వశ్చన్ అది. In a single step we can give the conclusion for this. సో ఇందులో ఒక చిన్న మోడిఫికేషన్ ఏంటంటే మ్యాట్రిక్స్ దట్ ఏడి ప్లస్ బీసీ అని డిఫైన్ చేసింది సార్. అప్ టు దిస్ షార్ట్ కట్ కొన్ని తయారు చేయడానికి కానీ చిన్న చిన్న మోడిఫికేషన్స్. ప్లస్ రిమైనింగ్ పార్ట్ కూడా సేమ్ సార్. మళ్ళీ ఫర్ ద sin x whole power x also you can write that, then it becomes very easy for the student.
డబ్బులు బ్యాంక్ లో ఉన్నాయి కదా, బ్యాంక్ ఏమని చెప్పించా కదా, తీసుకొని వెళ్ళు. సరే
ఓకే సార్.
రాడు, సాయంత్రానికి ఎప్పుడో వస్తాడు. సరే వస్తే వచ్చాడు లెక్క.
Next, some more regarding binomial theorem. So binomial theorem means the very first and fundamental point is x plus y whole to the power of n expansion. So the binomial theorem topic can be divided into two parts. The whole objective concept can be divided into two parts. The first part is when n is a positive integer. The first part is when n is a positive integer. Second part is if n is not a positive integer. If n is a positive integer, that is totally one part. First part of the binomial theorem. The second part of the binomial theorem is if n is not an positive integer. That means it may be according to our syllabus, or positive fraction or negative fraction. So majority of the questions are giving from n belongs to positive integer. Generally answer examination, especially in the syllabus of JEE main syllabus లో అయితే ఓన్లీ పాజిటివ్ ఇంటిజర్ మాత్రమే ఉంది సార్. ఓన్లీ పాజిటివ్ ఇంటిజర్. లాస్ట్ 2-3 years లో ఒక్క క్వశ్చన్ కూడా పాజిటివ్ ఇంటిజర్ కాకుండా ఇవ్వాలి. ఓన్లీ ద పవర్ ఈజ్ ఏ పాజిటివ్ ఇంటిజర్. సో ఇఫ్ ద పవర్ ఈజ్ ఏ ఇంటిజర్, if the power is a positive integer, then the expansion is valid for all the values of x and y. xy values ఏం తీసుకున్నా సరే valid. xy belongs to capital R. But then x plus y whole power n కన్నా maximum times we can use the 1 plus x to the power of n. ఇది ఎక్కువ యూజ్ చేస్తాం సార్. 1 plus x whole power n ఎక్స్పాన్షన్ చాలా ఎక్కువ యూజ్ చేస్తాం మనం. ఎక్కువగా rational terms, irrational terms, number of rational terms, number of irrational terms. So just a moment, I will explain some questions related to the binomial theorem also. For example, number of rational terms. టైం ఆల్రెడీ 3:10 అయింది సార్. ఈ కంక్లూజన్ చెప్పేస్తాం, తర్వాత మీరు ఏమైనా అడిగితే రిప్లై ఇస్తే మీటింగ్ కంక్లూడ్ చేద్దాం. ఇంకా బికాజ్ ఏం లేదు సార్, మళ్ళీ 2 to 3:30 పర్మిషన్ పెట్టి క్లాస్కి వచ్చా, మళ్ళీ 3:30 ఇమ్మీడియట్గా నేను క్యాంపస్కి వెళ్ళి మళ్ళీ నా క్లాస్కి అటెండ్ అవ్వాలి.
ఓకే సార్, నో ప్రాబ్లం.
సో నెంబర్ ఆఫ్ రేషనల్ టర్మ్స్ ఇన్ ద ఎక్స్పాన్షన్ ఆఫ్ 4th root of 5 plus of 4, 4th root of 5 plus 5th root of 4 whole to the power of 100 Fourth root of 5 plus fifth root of 4 equal to the power of 100. Find the number of rational terms in this. So how many rational terms will be there? Here there will be 2 points. The very first one is